Hi everybody, welcome to this video. My name is Martin. This is my first video I've made in quite some time. I want to go over PowerC with you. PowerC is one of the common programming compilers I like to use on the Commodore 64. I'm using an emulator today so I can capture the screen. As you can see, this emulator is a SuperCPU emulator, and I'll leave a link for it below if you're interested in using it. If you're using a regular Vice emulator, it's not going to make any difference. So, to begin with PowerC, you have to have the disks, and I will leave a link also down below for the disks for PowerC. There is the original disc that I got from a website, and then there is a D81, which is a 1581 floppy image that I created that contains all of the system files and everything all on one disk. For me, it makes it a little easier to use, and I will leave a link for that below. Also, we'll leave a link for the instruction manual for PowerC because you're going to need to take a look at that too. But I'm going to show you basically how you can use it to edit and compile and link together some code and make it run. So let's go ahead and get started. I'm going to get started by mounting my version of PowerC. If this will work. Why is this not working? It's working. Oh, here we go. And my version, PowerC D81. And now, with SuperCPU, you can do Jiffy DOS shortcut with the run stop, shift run stop. But right now, I'll just go ahead and type out load. 8,1. And as long as shell program is your first program on your disk, it should load up and run fine. Run. There we go. Now we're in PowerC shell. So, to begin with, while we're in the shell, there's several commands you can use in here. There's commands for moving files, which actually only moves the files on the same disk. There's a print, where you can print it to a printer or print the contents of a file to a screen. I'm not going to go through every single one of these. They are in the manual. I believe they are on page 8. But I am going to go through L, which will list a directory. I will go through, let's go ahead and mount another disk. Let's go put one on 9. And I hope that I have that set for D64. Let me see. Let's see here. Work 9, 0. And I did it. So I have my device on here on my emulator for device 9 is set to a 1541 and my drive 8 is a 1581. So the neat thing with PowerC is you can use a dual disk system with it. So, and even on my real Commodore, that's what I do. I have a 1581 and a 1541 that I use both. So this is a pretty handy feature. But now, if you type work, what you're doing is you're selecting the work disk that you want to work with. And so if I hit work 8, it's always, unless you have another device number, it's always 8 or 9, 0. Okay? So work 8, that will give us everything on our system disk. And a lot of object files on there and stuff you see. Now, if I were in my work disk on device 9, L won't pull up that directory, but L will pull up my work directory, but LS will pull up the system directory. So if I do LS, I get everything on drive 8. If I do L, I get everything on drive 9. So that's the basics of how to work with a shell. Now there is also there's going to be the editor, compiler, and linker. I'm going to go through those one at a time. So let's go ahead and begin with the editor. We have two options for the editor. Matter of fact, let me list the directory real quick for the system. I paused it, and if you see, there's ed.sh right under compiler, and there's ced.sh. What the difference is the ed is a regular editor, and it has no syntax checking. CED does have syntax checking, but as you can see, it's considerably larger, so the time to load it could be considerably more. Now, I installed Jiffy DOS on my 1581 here at home, and it made my 1581 so fast that CED loads up in a flash, so it's really no big deal. But we're going to go ahead and use the CED because we want to do syntax checking. It's kind of handy to check your syntax before you drop out of your program and then go to compile, and then it tells you there's an error. It doesn't catch everything, just syntax errors, but it's better than nothing. And it helps, like, if you're putting parentheses around something and you accidentally have one too many parentheses or one, not enough parentheses, it'll catch that stuff before you get out of the editor. So CED, you don't have to type any of the .sh extensions. Those are automatically assumed by the shell. Okay, this is the main syntax checking editor. So let's go ahead and write a test program. Now, mind you, how I included the stdio.h in PowerC, it doesn't care if you use quotation marks or the less than greater than symbol. It doesn't care. Either way, they're synonymous. And then we can type main, open, close, and now we have special keys. Okay, there are some special keys in PowerC that you have to learn. They are in the manual, and let me look it up real quick. Let's see here what we've got. Special keys. No. Almost. Here we go. Okay. For the curly braces, they are the shift, so you do shift plus and minus, and that'll give you your curly braces. So on your real keyboard, it's actually plus and minus. And then for a backslash, it will be the English pound sign, which, since I'm on an emulator, I've got to figure out which one that is. I think, yep, that's that one. So the English pound sign. I would tell you what the emulator keys are that I'm using, but what I've found is everybody's emulators seem to be different. I don't know how it works, but on my keyboard, I did just type the insert key, and it put a backslash. So, yeah, it's a little bit more difficult when you're on an emulator. I'll be happy when I get something to record off the real machine. Then there's a tilde symbol. The tilde is logo P. Commodore logo and P. Oh, there it is. Nice. That was painless. Okay. And then there's the underscore, which is logo and at symbol. Oh. Yep. There's at and there's underscore. So on your real keyboard, it's going to be logo at symbol. And then for the vertical bar, if you want to do a logical OR, you're going to do a logo and asterisk, which is, there it is. There's your two bars. This stuff is listed in the manual, page 14. I suggest you take a look at it and have that handy for reference to get used to this. So anyway, I'm going to do the shift plus minus. And now, let's see, printf hello viewers. And that was a pound sign. N. And there we go, we have a program. Now, in the syntax checking editor, what you can do is hit run stop, and it will come up with a command. For the command, you can simply type check or ch, and it will go through and check to make sure there's no syntax errors. Let's go ahead and make a syntax error. See what it does. See right there, syntax error, and it does stop on the line, and as I recall, when I hit enter, it will take me to that line. Right below it. Perfect. Now, run stop also, I'm going to show you how to save in a moment, but there's also something neat about this is it has different workspaces. So let's say I want to load another program or make another program. I can type go, or I think just go, and let's say 1. Bam. Now I'm in a different workspace. We didn't lose our other stuff, because if I want to get back to it, I can go main. And there is a way to list these spaces. Hold on 1 second. Okay, list. Now shows all of our spaces. So we have name and the blocks it's using. So there's our main, and then we have 1. If I go to 2, now it's clear. If I go to list, maybe just an L. Yes, just an L. And you can see there's main, 1, and 2, all these different workspaces and how many blocks free I have. So that's really cool, and it is handy to use that feature. But right now I'm going to go back to main. Okay, so now that we're in main, we want to save. Now, when you initially save, you can put, and you put is your save command, and you can type up the name, test.c. Make sure you add the extension .c or .h. It won't add it for you. And you can just go ahead and hit enter. And it should save it on my work disk. And I believe we can type dir, and we can get a listing of our directory on our work disk. Of course, test is not there at the bottom. Figures. dir, let me run through with caps on. I should have used a blank disk, because there's test.c at the very beginning. So there it is. Well, actually, I couldn't use a blank disk. I actually have to put, if you have a dual disk system, you will have to load all of your header files onto your work disk. Those have to be on there. So if you include stdio.h, all those header files have to be on your work disk. Object files do not have to be, but the header files do. Now, if we want to save, now let's say we've updated our program and we're ready to save. We want to save over that name. Then we have to put, and then open parenthesis, @ colon, test.c, and close quotation. And now this will save over our previous test.c. Now, let's see here. Let's clear this. And clear, of course, clears the workspace. Now if I were to go to 1 and I were to type hello, I'm 1, 7, I'm 1, and then I'm going to go back to main, and now if I go clear, I go to 1, it's still there. So whatever workspace you're actively working in, you type clear and it clears it. But it doesn't affect your other workspaces, so go back to main. And now let's load. By loading, we type get, and we can get test.c. There it is. So now, I believe what we can do is we can quit. Type quit. And now, next time you want to edit, let's see, type in ced test.c and it will load it for you. See? Nice and convenient. Quit. Now, time to compile. Now, if you're using a dual disk setup, you have two 5 1/4 inch discs. You got to swap your disk. You're going to type cc test.c. Okay, and what that will do is that will let you swap your disks, your system disk versus your work disk, and there's some libraries on the disk. I personally find that tedious. I haven't ever done that way. I made a 1581 disk as quickly as I could, and then also have access to two disk drives. So if you have a 1581 disk, you would also type P. Only time, well, type P to make sure if you have two disks to work with. But the only time, if you don't have any disks you need to swap, then you don't need to. You can just put the -P in there. But if you have to swap disks, forget the -P. Now we go test. I'm sorry, I hope that wasn't confusing, but test.c. This should compile it. Now that I've compiled, I want to tell you, when you update your program and you go back and want to compile again, all you have to do is type in cc -p or no -p test.c or whatever your program name, and it will write an object file over the previous object file automatically, so you don't have to worry about that. That was something I didn't know when I first started, and I was deleting the object file until finally I figured out it was already copying over it. Now it's time for the linker. Now for linking, generally, if we want to make a program that works just in the shell, we would just type link and go from there. But if you want to link a program that will be executable outside of the PowerC shell, you will need to type a -s. Now, if you just have a -s, it will load it up into basic memory, where you can basically load it and run it. Now, if you don't want it to be loaded into that specific memory location, you can go next to it and specify the memory location you want it to be loaded in. And I believe you can also specify it in hex. That would be the screen memory, but I believe you can do it in hex or you can do it in decimal. Now let's go ahead and we're going to link this so it runs in the shell. So we type link. Now we made a program called test.c. When it compiled, it outputted a file test.o. So first type in test.o. If we had any other object files we need to link in, now would be the time to do it. We would need to type those names in .o and link them all in. Since we do not, we do require the standard system libraries to be linked in, standard system object files. To do that, it is an up arrow. So up arrow on your Commodore 64. On my emulator, I hit the delete key and you press enter and it will link the system files. And then you just hit enter. And output name we will put is test.sh. test. Remember, we don't have to type the .sh, it's already assumed. Hello viewers, there it is. So now we have successfully edited, compiled, and linked a C program in PowerC. This C compiler is pretty easy to use. It's a lot of fun. I enjoy working on the native equipment. Normally I do whenever I can. And let's see what else. Oh, let me show you something else with the link. Let's try a link. And test.o. And let's see what happens when we don't put the up arrow. We just hit enter. Unresolved external references, CStart and printf. So if you're linking a program and you have other object files and you forget one, you hit enter and it will say, "Oh, I don't have references for these functions." So now if I hit the up arrow, we'll link those in, and then I'm going to show you the trick to overwriting your previous .sh file. So when we hit enter here, it's going to say output file name. I don't want to keep making new file names, so I want to, this time I will @ and colon test.sh. That will overwrite the previous sh file. Do not use quotations in there, because if you do, it will make another file and it'll be difficult to get rid of. It's kind of a pain. So when you're in the editor, you use quotations, and when you're in the linker, you do not use quotations. Sorry, but that's the way it is. Let's see. Oh, there is another thing we can also look at. Let's see if we have it on here. Lib. Yes. We have the library. Now this is a source file on your main PowerC disks. It needs to be compiled and linked. Okay, but this is a nice program, because this allows you to build your own libraries, and you can put all your object files into one library for whatever specific program you're making, or general use libraries, and you can load the library, save the library, clear, display all the contents of the library. Let me see if I even have a library on here that we can look at. Asterisk. What would I put for the extension on that? I'm forgetting. I did see .else swing by. Let's see. There's Conio.l. Okay, so I was working on making my own version of Conio. It's not included in the source disks, but let's go ahead and go lib, and let's go ahead and load. Type the first letter, Conio.l. And then it froze. Darn it. Okay. Let's see here. Let's see. Work 9.0. Let's see if we can try another. Why it froze, I don't know. I haven't used that one. Menu. Let's try menu.l. Hopefully one of these works. Load library, menu.l. Okay. Let's go ahead and see if we can find one on the work disk, because I think when I made a copy program that back up my software, and I may have made this disk during that time, and for some reason when it would copy, it did not copy the library files correctly. So I think that's the problem I'm running into. Let's go ahead and see if we can find one on the main disk. Here we go. stdlib.l. Lib. Okay, load stdlib.l. I don't think this thing, oh thank goodness, I didn't think anything was going to work. I'm like, this is great. Okay, now we can display a library. Hit D, and there are all the functions contained in the stdlib library. Pretty cool. And you can go through and you can remove them if you want to. You can add more. Do whatever you want. Look at all that. Page by page. Nice. So you can remove with R and then Q to quit. Okay, there is something else too that we need to discuss before I conclude this video, because, well, this is super important. Let's go back to, let's see, work 90. Let's go back to the editor. Okay, now let's go ahead and get our old program. Git test.c. Okay, in PowerC, it uses old style function declarations, so you won't be using the modern ones that you may be used to. It's going to be old pre-ANSI KNR style, and what it is you're going to make, let's see, prn print message, and let's go ahead and pass let's go A and message, and then notice that I did not list what types these are, because I list them underneath here. And I think I'm going to go with int for A and character pointer ms. And what we're going to do is we're going to print a message so many times on the screen. So let's go ahead and while A minus actually, you know what, we don't even need these. Just habit, I guess. Alright, that is our function. Now, with your function declaration here, you do not put a prototype up here unless you have some type of return value. If you don't put a return value right here, it is assumed to be an int. So let's go ahead and give a return type of, well, we'll just put int. Now with the return type on it, now you pretty much will need a prototype, especially if you're making a library, you want to use it somewhere else, you're going to have a prototype in your H file. But the prototype will not be like you probably would expect. It will be int prn message and no parameters to be passed. All it does is declare it and tell you what kind of return type, tell the compiler what kind of return type to expect. That's it. If you add parameters in here, it'll cause error. And now let's go ahead. Here's a neat little function. If you hit Shift Run Stop and then you push the down arrow, you just highlighted this line of code. Now if you hit F5, you've cut it. Now I can come down here and I could paste it with F6, but we don't need it. So Shift Run Stop. Oh, wrong one. Shift Run Stop again. Shift Run Stop down. F5. Get that out of there. So that's a nice little editor command. There's a number of little editor functions that you can learn too that are listed in the manual. And we'll be using them in time. So let's go ahead and call our function. Message. Let's say we want to print it 10 times. And we want the message to be hello again, viewers. There we go. And now let's check it. All good, no syntax errors there. Doesn't mean we're good to go because the compiler could still find an error, but that's a good sign. So let's save it, overwrite the old test.c. Hold on, test.c. And quit. CCP.c. Link it. Let me go to my settings. Go to my settings real quick, and let's go to drive settings. And I think it's here, right? No, it's not there. Settings. Options, maybe. Drive sound emulation. Thank God. There it is. Okay, let's turn that off. Alright, link. And let's go ahead and link test.o. And our up arrow, which on my keyboards, delete. And then we will test.sh. Let's see if it works. There we go. Perfect. So I need you to see that definitely. Almost forgot, but yep, it takes only the old style function declarations. Very important to remember. That's pretty cool. Now, there's some other stuff on here that I'm not going to go over yet. There's a formatter program. I'm not really sure on that one yet exactly what it does. I think it's supposed to clean up your code, format it in some way. There's a translator program. As far as I know right now, it translates it to German. I don't know. I have no idea. So um, when I get to those, I definitely will make a video about it too. But for right now, I think you have the basics of what you need to start writing your own PowerC software. So go ahead and go to the links I have below, get the manual, get the stuff, get onto PowerC. It's a lot of fun, and I'll talk to you next time. Thanks. Bye.